There's a fundamental paradox at the heart of the Artemis II mission. The more advanced our cameras become, the more fake the footage appears to the human eye. We are sending state-of-the-art CMOS sensors into a realm where they are technically overqualified, yet the results are often grainy, flat, and devoid of the detail we see in a $50 video game. This isn't because the technology is failing, it's because space is an optical battlefield. On Earth, our cameras rely on the atmosphere to diffuse light and provide context for the sensor. In the vacuum of space, that context is stripped away, leading the camera to struggle with a technical impossibility, capturing the blinding glare of a lunar morning and the absolute zero of the stellar background in a single simultaneous frame. There is the radiation tax. While you're watching a smooth feed from the Orion capsule, the sensor itself is being bombarded by high-energy cosmic rays that don't exist on Earth. This creates a technical paradox. To prevent these particles from frying the electronics, engineers must often use older, hardened sensor architectures with larger pixels. These pixels are more resilient to radiation, but have significantly lower resolution and higher noise floors than the smartphone in your pocket. What we perceive as low quality or CGI grain is actually the visible scar tissue of a sensor fighting to stay alive while its pixels are being struck by subatomic particles at near light speed. It's a literal battle between data and destruction. The final paradox lies in the glass itself. To get a camera to survive the journey, it has to be shielded behind layers of leaded glass and quartz that are inches thick. This creates an optical bottleneck where the most expensive lenses in the world are forced to look through what is essentially a thick, distorted bunker window. This glass doesn't just protect the astronauts, it introduces internal reflections and ghost flares that look like studio lights to the untrained eye. We are essentially trying to film a cinematic masterpiece through a submarine porthole. So, the next time you see a glitch or a flat horizon, realize you aren't looking at a mistake. You're looking at the hard-fought compromise of machines operating in a domain where the laws of optics were never meant to apply.